Hey guys, it's just Math, y'all. Back with another video on completing the square. Let's look at what we're going to do. All right, I have two more I want to do. Again, when we completing the square, we want A to be 1, we want B to be even. It's not hard when that happens. The patterns that are happening in this problem make the problem even easier. So let's try to pick up on some of these patterns this time. So the first thing we want to do is move our C to the other side. So that would require subtracting 30 on both sides. So that'll be a negative 30. My magic number is going to go in the blank. So now this time, B is 6. And half of 6 is 3. And 3 squared is 9. So I'm going to technically add 9 to both sides. That's the magic step, number 3. Now, I'm going to factor it. When I factor the left-hand side, what's half of 6 again? 3. This is going to factor into x plus 3, x plus 3. Yes, that's one of the coolest patterns. That's always going to happen. Let's go back and look at the other problems. Half of 14 was 7, and it factored into x plus 7, x plus 7. Half of 4 was 2, and it factored into x minus 2, x minus 2. Half of 8 was 4. It factored into 4 and 4. Sign goes with it. Notice I ignored those. So that's one of those patterns. So the factoring part should not be hard. So step 4, factor and rewrite. And then this is going to give me negative 21. Okay, then we're going to take the square root of both sides. One side cancels. And the other side, we actually do the square root. Now this time we're going to have an I and the square root of 21. So there we go. We're going to solve. We're going to subtract 3 on both sides. And my final answer is negative 3 plus or minus I square roots of 21. Again, that's two answers. Negative 3 plus I square roots of 21 and negative 3 minus I square roots of 21. Those are your two answers. Okay, let's move on to one that is hard. Completing the square always works. Always works. Now this one is the reason why we don't do completing the square. You will see it as we get started, okay? First thing, we're going to have to force A to be equal 1 by dividing, which means I'm going to have to divide everything. I'm going to have to divide everything by 2. So that gives me x squared plus 5x plus 17 over 2. I'm dealing with a fraction. And this is why when A is not 1, we might not want to use this method. But let's keep going. All right, we're going to move C to the other side. And that's going to be a negative 17 over 2. And now I'm going to add b over 2 squared to both sides. Here's my magic number. B is 5. 5 over 2 is a fraction. And when I square it, I get 25 over 4. So I'm going to add 25 over 4 to both sides. Again, I'm dealing with a fraction. And this is why we don't do completing the square on problems like the original problem. Okay? Okay, so now we factor the left. We're going to have x plus 5 over 2 and x plus 5 over 2. I don't have to do that work because there was that pattern. Remember the pattern in the previous problem I showed you about? But I do have to add these fractions. And I'm going to have to get a common denominator or use my calculator or something. And I'm not teaching anybody how to use fractions today, but that's going to be a negative 34 over 4 plus 25 over 4, getting common denominator, which is going to be a negative 9 over 4. Is that right? I think it is. I think it is. So that's negative 9 over 4. So now I'm going to take the square root. And I get x plus 5 over 2 is equal to plus or minus 3 over 2i. So I'm going to solve. I'm going to subtract 5 over 2 on both sides, and I get negative 5 over 2 plus or minus 3 over 2i. There's my two answers. Now, on the quadratic formula, you would normally do this problem on the quadratic formula with like negative 5 plus or minus 3i over 2. That's the same answer. But that's it. That's completing the square. It's just math, y'all. Try it out. I won't give you any of these hard ones like this last one, but make sure you go back and learn how to do the easier ones because they are pretty cool, and it sure is better than the quadratic formula. Okay? It's just math, y'all. See you next time.